Hello, welcome. Let's try to solve a Leetcode problem. 2536, increment submatrices by 1. So the idea is that we are giving the queries, and the queries just means an area. So for example, 1, 1, and 2, 2. So for the coordinate 1, 1, 2, 2, 2, in this area, basically, for this query, so we're gonna plus a 1 in this area. So for example, for another query, so 0, 0, 2, 1, 1. So in this area, so we have plus 1. So this means the final result. Only in this areas, it's gonna be only in the middle in this area, so it's gonna be 2, and we're gonna return this kind of a matrix. So this kind of problem. So first of all, we might use the brute force. Because if we didn't know how many queries or what is the size of the square, what is the size of the n, so basically maybe we're gonna use brute force to check if we can just plus. So for example, if we have a query in this area, so in this area we're gonna have a plus 1. If we have a query in this area, so in this area we have a plus 1. As this number n and the query gonna be large, so this is 10 to the power of 4. So if we use brute force, basically the time complexity gonna be 10 to the power of 8. Because we have 10 to the power of 4 queries, and for each of the queries it's gonna be n squared. So it means it's gonna be 10 to the power of 8. Definitely it's gonna be time limit exceeded. So let's just try this method first. So we're gonna prepare a DP array. So I'm gonna use f. So it's gonna be 0 times n. So for r in range n. Now we want to just to check all the queries. So I'm gonna use x1, y1, and x2, y2. So this is just for each of the queries inside the queries. So I want to check the row and column. So for r in range x1 to x2 plus 1, and for c in range, so y1 to y2 plus 1. And we want to put values inside, so frc, so the plus equal to 1. And finally, we just want to return the DP table f. As you can see, it works, but it cannot pass all testing cases because, as I said, the time complexity nearly 10 to the power of 8. Definitely, it's gonna be time limit exceeded. So if it is not possible, normally we're gonna try to improve it like the prefix sum. While we are solving the problems in a 2D table, in a matrix, we can use prefix sum. But here, maybe we're gonna use a 1D difference array to solve the problem. So this means it's gonna be time limit exceeded. Maybe let's just wait for a few seconds, and we will see it's gonna be time limit exceeded. As you can see that we cannot pass all testing cases, only passed half of them. Now we try to improve it. So we're gonna use the second method. So it's gonna be 1D difference array. So I'm gonna maybe I'm gonna copy these areas because I want to change a little bit. So the 1D difference array idea is that because we have this kind of matrix, let me prepare another drawing maybe. So in these areas, so while we are checking these areas, for example, so we're gonna check row by row. So in this row, we're gonna use a difference array. So here gonna be a plus 1, and at the end, after that, this place is gonna be a minus 1. I mean here. And similarly for all other rows, it's gonna be a plus 1 and a minus 1. And after all the calculations, I'm gonna use the accumulated sum for each of the row, and then just return the final result. So currently, the first method is 1D difference array. So now let's try to change this to 1D difference array. So for the f function, as we have a start and end, but it's gonna be add plus 1. So for 0 should times n plus 1 for the column. And for the row, it's going to be the same. Now we want to check the queries, but currently we don't need to check all the columns. We just need to check one row. So for r in range x1 to x2 plus 1, and similarly the f function can also change. So the f y1, this is the column, gonna plus equal to 1, and fy2 plus 1 is gonna be minus equal 1. I hope you are familiar with the 1D difference array. Basically, this is just the formula of how to calculate that. Yeah. So finally, we just need to return the accumulated result. So let me put an array, and inside it's gonna be a list accumulate row. We need to remove the last element in each of the row. So it's going to be for row inside F. Yeah, I'm not sure if you are familiar with all the calculations. I just to make it simplified, I put it inside an array, and this is going to be the list accumulate each of the row, but I just wanted to remove the last element because this one is just for calculation. So I just remove the last column and accumulated the prefix sum of each of the rows, and then I get the final result. So this is totally the difference array idea. Now, let me just run it to check. Int object is not iterable. Let me check why. Yeah, I don't need that. I don't need to let me think. So for each row, yeah, because this is not F, this is the in this row it's gonna be fr y1 and fr y2 plus 1, because this is just a 2D array. Now let's just have a check. As you can see, it works. Now let me just submit it to check if we can pass. As you can see, we passed, and now the time becomes less than 1 second. So before, we cannot pass. Now it is much faster than before, because the time complexity becomes, the query is gonna be 10 to the power of 4, so this is the queries, and for r in range, so for this loop, this gonna be n, so n gonna be 500, yeah. So normally it can pass, because it is 5 times 10 to the power of 6. So this is 1D difference array. Now, we want to optimize this solution to a 2D difference array, because 2D difference array is going to be much faster than this. So let me just make a comment for this code, and just copy it here to prepare the 2D difference array. So the 2D difference array idea is similar to the 2D prefix sum. So for easy calculation, I'm going to prepare a padding at the top and the bottom, and at the left and the right side, I'm going to prepare a padding to be in this areas, it's going to always be 0. So this is just the padding. And the formula for the 2D difference array is that at each position, so for example, in these areas, I want to calculate the accumulated sum in these areas. But before that, this is a 2D difference array. I need to plus a value 1 at these areas. So, yeah, because I want to, basically, I want to calculate all the accumulated ones in these areas, right? Yeah. Yeah, I want to calculate all the accumulated ones in these areas. Maybe, let me just let it go back. Maybe some areas it is 2, or some areas it is 3, or some areas it is 4, it is 5. It doesn't matter. But before that, I want to prepare the 2D difference array method. Yeah. So the first step is that at these areas, we're gonna prepare a plus 1. This is similar to 1D difference array, and it is similar to the 2D prefix sum. So for 1D difference array, at the start of the position, we're gonna have a plus 1. Here, we prepared a padding. That is why we prepared a padding, because we're gonna prepare a plus 1 just out of this dot. Out of this corner, we're gonna have a plus 1. But at these areas, yeah, let me make it longer. Yeah, so at these areas, we're gonna prepare a -1, and similarly at these areas just below it, we're gonna prepare a -1. So here we have a -1, and here we have a -1. So this means in these areas it minused twice. There is an overlap of minus. So this means in these areas we're gonna have a +1. So this is the preparation for the 2D difference array. After that, we just use a 2D prefix sum to solve the problem. Yeah. So this is the first step we're gonna prepare. So if this is the query, x1 and y1, so we just go out one step. So it means x1 -1 and y1 -1. It's gonna be these areas. Yeah. Yeah. But for us, we prepared a padding. So it's going to be x1 +1 and y1 +1. So for example, if we wanted to check x1 and y1, if it is here, now we prepared a padding. So it's going to be x1 +1 and y1 +1. It's going to be here. Yeah. And similarly for others, because we prepared the padding. And similarly for these areas, we just prepare a x1 +2 and y1 +2 because it goes out. Yeah, normally it should be x1, y1, and x2 +1 and y2 +1. But we prepare a padding, so it's going to be x1 +1, y1 +1, and x2 +2, and y2 +2. And after all those preparations, we're going to prepare the prefix sum. And the prefix sum should be easy. If we are going to calculate this dot, the prefix sum of this dot for 2D array, basically we wanted to check all the values before it, I mean these areas, and all the values just go up, yeah, at the left side, and all the values at the top side. So for example this area, but there's a duplicate, that means we need to minus these areas, yeah, so plus this area and plus this area and minus this area. So it's going to be the accumulated sum for this dot. Now we just need to finish those two drawings by the coding. So we need to change it. There are so many methods for this kind of 2D difference array, but for me I want to prepare a padding. So if I prepare a padding on top and bottom, it's going to be n+2, and at the left and right side also for the rows it's going to be n+2. Now this is the first step. Now for the second step, I just want to check the queries, and I don't need to do that. Yeah, because I want to optimize the time complexity. Basically, I don't need another for loop, and I can calculate it directly. So for the x1 +1 and y1 +1, I'm gonna set a +1. So this is just in these areas. So for example, if x1 and y1 is 0, 0, so currently x1 +1 and y1 +1 is going to be in these areas. So from here, I'm going to prepare a +1, a positive one. I'm going to prepare a +1. And then at the end areas, I'm going to prepare another +1. Yeah. So similarly for other areas, so x1 +2, yeah, let me set it to x1 +1 and y2 +2, so the minus equal to 1, and fx1 +2 and y2 +1 gonna be minus equal to 1, and fx2 +2 and y2 +2 gonna plus equal to 1. Yeah, so this means in these areas, so first of all, as we prepare the padding, normally it's going to be x1 and y1, but we prepare a padding, so it's going to be x1 +1 and y1 +1. So normally in these areas, it's going to be x2 +1 and y2 +1. As we prepare a padding, so in these areas, it's going to be x2 +2 and y2 +2. The padding at the left and right and the top and bottom. And similarly for all other areas. So for example, in these areas, it's gonna be x2, it's gonna be x1 plus 1 and y2 plus 2. So this is y2 plus 2, and the x place is going to be the same, x1 plus 1, and also this is this place, and another place is let me check, it's going to be this is here, so another place is here. Yeah, another place is here, so the y place is going to be the same, so it's going to be y2 plus 1, but for the x it's going to be x1. Yeah, I did something wrong, because at this position it's going to be x2 plus 2 and y2 plus 1, because y didn't change. And here it is x2 x2 plus 2, and yeah, this is let me check, this is x1 plus 1, and y2 plus 1, and yeah, this is gonna be x2 plus 2 and y1 plus 1. Yeah, because for this one x1 and y1, for another prison, let me just check the drawing. Yeah, because for this prison we are sure it is x1. Yeah, let me just maybe make another drawing. It's not so easy to see it. Yeah, so in these areas, so this position gonna be x1 plus 1 and y1 plus 1, and in this position it's gonna be x2 plus 1 and y2 plus 1. And now I want to check this position. So this position is going to be the so for the row it is x, and for the column it is y. So it's going to be yeah, for the row it's going to be this going to be x2, and the column going to be the same. So this going to be x2 plus 2 and y1 plus 1. Yeah, so x2 plus 2 and y1 plus 1. And now I want to check these areas. So these areas it's gonna be the column gonna be this yeah, so the column gonna be y2 plus 2, but for the x it's gonna be x1 plus 1, and y2 is going to be plus 2. So because here is y2 plus 2, this is not 1, it is a 2, and this is x1 x2 plus 2. Yeah, let me just maybe clean up a little bit. So this is x2 plus 2 and y2 plus 2. Yeah, so this means here for the row it's going to be x1 plus 1 and y2 plus 2. So I think the formula should be okay. So if you are not sure with it, better to make a drawing. Yeah, because this is going to be the first step for the difference array. And the second step is that we want to prepare the accumulated sum. Yeah, maybe I want to make it easier. Definitely we want to remove the first row and the last row. So from here it's going to be 1, 2, minus 1. So this means that we're going to remove the first row and the last row. Now for each of the row, we want to remove the first column and the last column. So inside each of the row, it's going to be row 1 and -1 for row in F1 -1. Yeah, you must be very familiar with slice for Python because it's going to be very convenient for us to calculate how to slice the array or matrix, as you can see. Now let me just submit it to check. Oh, I forgot. This is not right. Yeah, this is not right because I don't need the accumulated sum. It's not a 1D array. It should be 2D array. So this is my row, and this is my column. So this is going to be the final result. But before that, I need to prepare the 2D array prefix sum. So I need to check. So for r in range from 1 to n plus 1. So as you can see, this is just in the it is just in these areas. So this is our padding at the outside. We are just focus calculating in these areas because we're gonna return these areas. So this means we're gonna need a prefix sum to calculate all those areas. So for say in range 1 to n plus 1, we want to check FRC gonna be plus or equal to, at the left side it's gonna be r -1. At the left side it's going to be RC -1, and we're going to plus at the top side it's going to be R -1 with C. Yeah, as we accumulated too much, we need to minus the overlap, so it's going to be FR -1 and C -1. Yeah, so it's all about mathematical formulas, about calculations. We should be careful about that. Now let me just run it to check. As you can see, now it works. Basically, we need to maybe we need to know 4 formulas. So this is maybe just one formula. Maybe we just need to know 2 formulas. This formula is for 2D difference array, and this formula is 2D prefix sum. So according to the drawing, in these areas, we're gonna use those 4 formulas. Basically, it is one formula. We're gonna prepare the 2D difference array. So as we prepare the padding, so in these areas at the top left corner, we're gonna have a plus equal to 1, and at the bottom side, now it is at the bottom side, we're gonna minus equal to 1, and at the right side, we're gonna minus 1. As we have a duplicated minus, we're gonna plus it. So at the bottom right side, in these areas, we want to plus 1. So this is why we plus 1. And for the 2D prefix sum, I think this is easier to understand. If we are familiar with the 2D prefix sum, we know how to calculate it. Basically, for each of the positions, maybe for 2D prefix sum. So for each of the positions, we just want to check the left side and the top side, these areas, and the left side of these areas. Yeah, plus this one and plus this one, just minus this one, and also plus the number at this dot. Yeah, so this is going to be the total solution. As you can see, let me just run it again to check if we can improve. Yeah, as you can see, it is much faster than before. It becomes 0.2 seconds, because currently the time complexity becomes the maximum of the length of the queries. It is 10 to the power of 4, if I remembered correctly, and this is n, and n times n, it is n squared. So it is the maximum of 10 to the power of 4 with n squared, and n squared is like 500 squared. So it's going to be 2.5 times 10 to the power 2.5 times 10 to the power of 5. So that is why it is much faster than before, and this is the best solution for this problem. Thank you for watching. See you next time.